viewers. This is Dr. Kazim, Initiative Support Center for Mathematics and Statistics. Today we have to look into sine rule derivation. The first things we have to do when you are doing the derivative of the sine rule is to firstly have your probably equilateral triangle like this, so that you name it triangle ABC. It can also work for isosceles triangle. So when you have this, take note that the side facing A is your side small a, while the side facing B is your side small b. The side facing angle C is your side small c. So having do this, you have to, this is not a right angle triangle. So, and your sine rule works for anything that is related to right angle triangle. So from there, you can be able to have your height like this in 2 dimensions. You can have another dimension of the height like this in 2 dimensions. From where it forms, you can label here n, while you label here n. So therefore, if we consider it like this, we can split it into 2, so that we have something of this nature like this. The second one will be like this. If you look at it, this is height, this is also height. Then from this side, here will be angle A, here will be angle B, here is a angle C, here is angle C. Then you can consider the hypotenuse. For this side is a small b, for this side is a also, for this side, this is our small b, then for this side is our small a rather. So here is your small a. So this is all what we need. You can have your n here, n here. This is all what we need to prove. But before we start the proving, this is actually what we want to prove, that a over sine a to be equal to b over sine b to be equal to c over sine c. The hint we have to follow is that there is what we call SOHCAHTOA. That is what we call SOHCAHTOA. This so means sine of an angle is equal to opposite over hypotenuse, while the ka means adjacent over hypotenuse, and toa is opposite over adjacent. We don't actually need ka and toa. This is all what we need. So because we are proving the sine rule. So as we are proving the sine rule, so what we are now saying is we only need sine of an angle. Let's start with our sine A. Where do we get our capital A? Which is this place. Opposite is hypotenuse over opposite is h, and the B is our hypotenuse. So we can have it as a h over b. If you cross multiply, you have your h to be equal to b sine A. You can call this one your equation 1. Then you go for b now. So if you have a sine b, you go to where you have b, which is h over a. This is your opposite, this is your hypotenuse. So your height over small a. If you cross multiply, you are going to have a h is equal to a sine b. You can call this one equation 2. Since this one is h, this is also h, you can equate them so that you equate equation 1 and your equation 2. So you have a sine b to be equal to b sine a. So in order to get where you are going, divide both sides by sine a sine b. So you have a sine b over sine a sine b to be equal to b sine a over sine a sine b. If you look at it from the left hand side, your sine B will cut. While from your right hand side, your sine A will go. You are left with so what we are saying is you can cross them out like this. When you cross them out, you are left with A over sine A to be equal to B over sine B. So this is just one dimension. You have to go for the other dimension when you will split your triangle like this. When you split your triangle in that way, you are going to have something like this. It's a right angle at M. So you have your height in this place. You have your A here, you have your C here. Then you also have your hypotenuse to be B. Then the other side, which is right angle at M, you have your B here, you have your A here. So this is still your height, while here is your C. That's how you split it if you consider it in this direction. Now, let's consider the side of B, which is here. We can say our sine B is equal to opposite. This is the opposite, which is hypotenuse here, which is H here over hypotenuse here. So you are going to have H over C. If you cross multiply, you have your H to be C sine B. You can call this one equation 3. You've used the other one as equation 1 and 2. Then you consider C, which is sine C, to be equal to, where is our C? Your C is here, which is opposite over hypotenuse, H over B. If you cross multiply, you are going to have your H to be equal to B sine C. You call this one equation 4. So from here you can equate your equation 3 and equation 4, since it's height is HH. So you have your B sine C to be equal to C sine B. So therefore, in order to get what you are looking for, you divide both sides by sine B sine C. If you divide both sides by sine B sine C, you have B sine C over sine B sine C to be equal to C sine B over sine B sine C. So this, we are getting to where we are going. You just have to cross sine C here, sine C here, sine B here, sine B here. So you are left with a B over sine B to be equal to C over sine C. And you recall that we've already proved B over sine B earlier to be equal to A over sine A. So therefore you are going to have A over sine A to be equal to B over sine B to be equal to C over sine C. Proved.